Okay, so let's take a look at question number 4. Right above the equation, I'm going to go ahead and write down the general equation of sine, which is A sine B theta minus C plus 1. We're going to go ahead and identify the values of each variable. So I see that A equals 3, B equals 2, C equals pi over 6. Remember, in the original, it's minus C. So if there's a minus, your C value is going to stay positive. But let's say if it was plus pi over 6, your C value would then be negative. And your D value here is positive 1. So the first thing you want to do is identify your midline, which is given by your D value, which is 1. So I'm going to go ahead and draw our midline. And then we're going to go ahead and use the amplitude to figure out the top half of the sandwich and then the bottom sandwich. So your amplitude is 3, so from the midline you're going to go up 3, 1, 2, 3. And so you know the top of the sine graph is going to reach this graph, or this line, which is your maximum. You're going to go from the midline, this time you're going to go down 3. So 1, 2, 3. This guy right here is going to be the bottom part of your graph, and that is the minimum. So you always want to draw your template of where your graph is going to be sandwiched in between. So now we're going to go ahead and find our phase shift. So our phase shift is this parentheses, and you're going to set this equal to 0. So you have 2 theta minus pi over 6. And you're going to go ahead and set that equal to 0. You want to go ahead and get theta by itself, so you're going to add pi over 6 to both sides. Remember, pi is just a number, so don't let those fractions confuse you. Bring down that 2 theta, 0 plus pi over 6 is pi over 6. Remember, your end goal is to get theta by itself, so I'm going to go ahead and divide by 2. Dividing by 2 is the same thing as multiplying by 1/2. So I get theta equals pi over 12. Notice that this value is positive, so that means I have a phase shift to the right. Okay. The next thing we are going to find is the period. So the period is represented by the letter T, and you find the period by taking 2 pi and dividing it by b. Remember, we said our b value was 2. So 2 pi divided by 2, those 2's cancel out. Our period is pi. So at every pi interval, the graph will complete 1 full cycle. So let's go ahead and actually graph this now. Now when you graph, you want to start off with your phase shift. And we know that instead of starting on the y-axis, this time we're going to start at pi over 12. Now if you look on the graph, notice here that pi over 12 isn't here. It's with pi over 4, pi over 2, and so forth. Well, pi over 12 is a teeny tiny fraction, so you're thinking about where is pi over 12 or 1 over 12 going to be on this axis. So I'm going to show you the long way of doing it so that you can see it more clearly. I'm going to do it on a separate sheet of paper. Now with fractions, something that we learned in like 2nd or 3rd grade, you always want to compare fractions by making sure you have the same denominators. So right now we're looking at pi over 12, right? We want the denominator of 12. But look at this graph here, I have pi over 4. So I have pi over 4, and I want to turn this fraction so it has 12 as its denominator. I multiply by 3, so I get 3 pi over 12. So instead of pi over 4, we have 3 pi over 12. That is the exact same thing. If you look on our fraction here now, we have pi over 2. If I were to rewrite pi over 2 so that it has a denominator of 12, I multiply by 6, multiply by 6, so then I have 6 pi. So then I have 6 pi over 12. Next one I have is 3 pi over 4. I want to rewrite this so that it has a denominator of 12, which I get there by multiplying by 3. Multiply the top by 3. 3 times 3 is 9 pi. Pi would just be 12 pi over 12. So I'm just showing you this way so that now you can easily see where pi over 12 falls on this graph. So if you look here, 3, 6, 9, and this is 12 pi over 12. If I'm looking for pi over 12, pi over 12 is going to be basically right next to the y-axis right here. I'm estimating this part to be pi over 12. So this is the small phase shift of where my graph is actually going to start. Hopefully that makes a little bit more sense. At this point, it's all about the fractions, not so much the trigonometry here. So we're going to go ahead and start our graph. Bring it back to this one. We're going to start it at pi over 12. And remember, we said our period is pi, so it's going to take pi to complete one full cycle. So instead of from 0 to pi, basically it's going to go a little bit past pi. And my graph is going to complete one full cycle in that frame. So remember, sine always goes up, down, and then back up. And I can continue it. And that is how you graph this function here. And that's it.